Okay, assignment 8, part 4. First of all, when we draw or sketch angles, okay, we usually draw those on a coordinate plane. So the positive go this way, so it opens up. So these are positive angles. And the way it goes is this is 90, this is 180, this is 270. We started at 0, but when you do a full circle, it's also 360. For negative angles, those open down, or this goes counterclockwise, this goes clockwise. So that would be negative 90, negative 180, negative 270, negative 360, and 0. And it keeps going, negative 450. This can go in. It can go in 450, 540. I don't think you'll see angles that big, but right. So when we draw angles, if they're positive angles, they open up and they go this way, 90, 180, 270, 360. If they're negative, they open down. And what we need to use this for is to find the reference angle. Okay. Okay, so that's an acute angle. And here's a new word. It's between the terminal side, ending side, and the I always say closest x-axis. And they are always positive, no matter if they give us a negative or a positive angle to start with. Our answer for our reference angle is always positive. So let's look at what this is, and then we'll get into some examples. So let's say I want to find the reference angle for 135 degrees. All right, so drawing, this is a positive angle, so this is 90, this is 180. So 135 is somewhere in here. So that would be our 135. So the reference angle is always to the closest x, never to the y. Ooh, I gave you let's scratch. That's a bad example. Let's go with 140. Okay. Let's go with 140. It's a better example. So it's always to the x-axis. So to find the distance, what's the distance between 140 and 180? So our reference angle is 180 minus 140, which is 40. Okay, so that angle in there is 40. So for a reference angle, we will always use 0, 180, or even 360. I don't think they give you big numbers, but we'll find out as we go through it. So here we're using 180. It could have been 0. It could have went further. It could have went to 360. So the reference angle is the distance between the terminal side. That's where the angle ends. So that's kind of a new word. Alex didn't really talk about that before. And the closest x-axis. So it's always going to be less than 90. That's why this is an acute angle. All right. So let's try number 1, 300. And you don't have to draw it if you can see it. I just like making a quick sketch. So 300 goes around there because this is 270, this is 360. So that's 300. If we go to where it ends to the closest x, what's that distance? Hopefully you come up with 360 minus 300, which is 60. That's your reference angle. Okay. Remember, always to one of the x-axis, either the positive side or the negative side. It's always an acute angle. So 108. So here's 90. Here's 180. So 108 is probably somewhere right about there. So that would be your 108. Now your reference angle is to the x, never to the y. So there's our reference angle. So 108 and 180. So I'm going to go 180 minus 108. Always do the bigger minus the smaller, because we know it's going to be positive. And that gives us an angle of 72. Okay, now we have a negative 144. So negative 90, negative 180. All right, so 144 must be somewhere in here, negative 144. Okay, so remember, reference angle is always to the x, and you can ignore the negative. So all you have to do is the bigger minus the smaller, and that gives us 36. So your reference angle there is 36. How much more does it take to get to the 180, or in this case, the negative 180? Okay, so we're still, even with the negatives, we're still using 180, 360, or 0. And last one for degrees, 75. Okay, so we're over here, 75. We started from 0. We're going back to there. So what's that distance? 75 minus 0? 75. Those are easy ones. Okay, now we're about to do the same thing in radians. So in radians, the positive angle still goes the same way. It goes counterclockwise or opens up. So this is pi over 2, or I like to think of it as half pi. So that might help us to think about it as 0.5 pi. That might help us, even though we're going to need fractions for our answer. This is pi. This is 3 pi over 2, which is 3/2 pi, which is 1.5 pi. And this is, we started at 0 and it comes around to 2 pi. Now going for a negative angle, it just goes backwards. And this is in radians. Negative angle, sorry about my bad picture, it opens down, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And remember, we started at 0. So same thing for reference angle here. We should only need pi, 0, 2 pi, or once again, pi, 0, 2 pi. All right, so let's take a look at some problems. Okay, so negative 13 pi over 12. Okay. What I like doing, I can see this, but I have more experience. I like doing the 13 divided by 12, which is 1.08. All right, so we know that it goes a little bit beyond -1 because here's our negative pi. Here's our negative 3 pi over 2, which is 1.5. All right, so here's our negative 13 pi over 12. Now, unfortunately for the reference angle, you can't use this decimal. That's just good for figuring out where it goes. So I'm going to do 13 pi over 12 because that's the bigger number minus pi. Okay, so we need to get common denominators. So we multiply this by 12 over 12. And that's 1 pi over 12. Or that it should take that, or pi over 12. Okay, so you have to, excuse me, you have to use fractions for this. You have to use pi. Okay, you can't use the decimals because they want exact. Okay, so next one, number 2, pi over 5. That's 1/5 is 0.2 pi. Remember, this is 0. This is pi over 2, which is 0.5. So it's right in there. And that's the easiest. Pi over 5 minus 0 is pi over 5. Anything that's right next to the beginning off of 0 is really easy. It's the same thing. Okay. If you'd like to try these two, pause it. I'm going to continue on. We got a couple more for you after this. So if you want to pause this, go ahead. Okay, so 1.2 pi is 6 pi over 5. So I'm going back to here. So I'm going to go 6 pi over 5 minus pi, which if I multiply the top and bottom by 5, it's 5 pi over 5. So that's 1 pi over 5. So pi over 5. Okay. Negative 7 pi over 5. That's 7 over 5. Just double check that. 1.4. Okay. So that's negative 1.4 pi. So remember, this is negative pi. This is negative 1.5 pi. So we're over here, and we want this reference angle right there. So we're going to go 7 pi over 5 minus pi, which we need common denominators. So we're going to multiply top and bottom by 5. So we get the common bottoms. So we get 2 pi over 5. Remember, always go to the x-axis. Last two. All right, if you want to, 1, 2, 3, 4, 5, 6. If you want to try this one, go ahead. I'm going to continue on with the answers. So 23 over 12 is 1.9 pi, roughly. Not exact. So that's pretty close to, all the way around, that's pretty close to 2 pi. So our graph's going to be here. So it's 23 pi over 12. Okay, so here's our reference angle. So I'm going to go 2 pi minus 23 pi over 12. Now we need common denominators. So I'm going to multiply this by 12 over 12. So 24 pi over 12 minus 23 pi over 12 is 1 pi, so pi over 12. Okay, then 13 over 15 is like a 0.86 pi. So we're gonna go positive. Remember, this is 1 pi, so it's going to be somewhere before that 1 pi. It's bigger than that half pi. Okay, so 13 pi over 15. We're gonna go the bigger minus the smaller. So pi minus 13 pi over 15. So multiply by 15 over 15. 15 pi over 15 minus 13 pi over 15 is 2 pi over 15. Okay. And these are all your reference angles. Okay. And that concludes this video.